Hi there. Now for this next part of the question, we were given then that 2x plus 1 was a factor of f of x and asked to now couple this with part A, where we knew that b minus a was 48, to find out the values of a and b. And as you can see, a turns out to be minus 96 and b turns out to be minus 48. So it's essentially using the remainder theorem again and working with simultaneous equations. Some people might say, well, I'm going to use the factor theorem. It's still essentially the remainder theorem, only the remainder will be 0. The tricky part here maybe is that we're told that 2x plus 1 is a factor of f of x, and it's establishing this value of p. The value of p for 2x plus 1 turns out to be minus a half. You've got to think of this as 2x plus 1 equaling 0, and what would x be if that were the case? Rearranging it, you'd have x equals minus a half. So substitute minus a half into f of x, equate it to 0 because we've got no remainder, or the fact that it's a factor of f of x, it would have no remainder, and then expand it out, and I've chosen to make b the subject. B would equal, in terms of a over 2. Okay, and then multiplying through by 2 gives me a equaling 2b. I've labelled that 1, and I can couple that with the equation we established in part A as b minus a equals 48. So by substituting 1 into this equation here, that allows me to get the value of b, which turns out to be minus 48, and then I can substitute that value back into equation 1 here, and that gives me the value of a being twice the value of b, so a turns out to be minus 96, and that gives us our two values, a and b. Okay?